No problem. You can see my CC64 small c?
Yes.
Yep. Excellent. Good.
Yeah,
so
nice and sharp.
I'm talking about an old student time project of mine, mostly, which I presented a month or two ago at the Euroforth, and Peter asked me to talk about this in this round again. So here I am. A small C compiler on the Commodore 64. Now, why would one write a C compiler on the C64 in 1989? The biggest reason was that I thought I could. Probably a key reason for a lot of computer software to be made. The inspirations I had was a similar small C compiler by Ron Kane and James Hendricks, published in a Dr. Dobbs book, in the case that I got it. And of course, the Dragon book, the iconic compiler maker's manual. The reason I wrote it in Forth is that this was pretty much the best, most powerful IDE and programming language for any practical purpose that I could find on the Commodore 64. One of the biggest advantages there, especially on the small machine, was the compact code. Well, I'm sure pretty much everybody around here sort of has been there at some point. So this is what a classical C compiler looks like, from which I had to strike quite a lot to limit the scope or get the scope manageable for me. So typically you have a source, it goes through a preprocessor, which replaces stuff, then goes into the scanner, which produces tokens. The parser will produce a syntax tree. Code generator will produce assembly. It might go through an optimizer, then into assembler, which produces object code. And then the linker eventually produces an executable. So this is what I made out of it. I scratched the preprocessor, mostly. Scanner, tokens, parser are there. Abstract syntax tree as such, not really. Code generator skips all the optimizer and assembler steps. Well, the fourth assembler somehow is involved, but we get to this. But essentially, this produces almost runnable binary code, which then at the end gets put together by I would call it a mini linker, linked with a runtime module to either produce an executable or a new runtime module. The properties of the language. So what is the small in the C of the compiler? First of all, it's still kerning in Ritchie. It's int and char as basic data types only one level of pointer, so no pointers of pointers, no unsigns, no long, no floats, etc. So really just int and char, and also no goto, at least so far. The shortcut I took with a preprocessor is that I implemented define as compiler constants. There was a convenient gap in the semantics of C back then, which kind of asked for that. File include is, of course, well, not of course, but file include is still there. There's no symbolic linker. The sort of overall model that I had in mind for this thing was pretty much Turbo Pascal 3. So you have a very, or hopefully reasonably quick compiler, which in one pass essentially produces your binary, your com file in Turbo Pascal's case. So no extensive library concept yet. The parser is handwritten. It's a top-down recursive descent parser, like the default thing that you produce when you go about handwriting a parser. The parser nodes call the corresponding code generator nodes one-to-one. So that is why there is no explicit materialized syntax tree. It pretty much gets eaten up the minute it gets constructed. The code gen is based on a 6502-ish, I want to call it, 16-bit single register stack virtual machine. And the implementation of that VM is via code templates, so binary code templates, and to produce those, the 6502 fourth assembler is utilized. Here's an example what the recursive descent in the parser looks like. So this is the code for parsing the logic OR and logic AND operator. First thing that the logic OR does is it descends to the higher priority logic AND, which then does the same, goes to the next priority bit OR. And after the next higher level is handled, each level looks, is my operator coming? If yes, I'll call something on the code generator, call my next higher node again, and so on. Nice thing is that at least in this part of the parser where you're dealing with binary operands, and logic AND and OR are a little bit special in C because they stop evaluating as soon as the result is clear from the first operand. But all others, the handling is pretty much the same. The only difference for each operator level is you need to know what's the operator you're looking for, what's your next higher priority, operator precedence, partner, and what is your code generator correspondent. And this lends itself, of course, very, very nicely to a defining word in forth. So this is actual code from the parser. Only I reversed the order in the real forth. Of course, the higher precedence later called called by lower precedence operands come first. So I reversed the order here. This is what the code templates look like. So the concept of the machine is I've got one accumulator-like register, which is living in the 6502 A and X registers. I implemented a soft stack for the local variables through 0-page, 1 or 2 0-page pointers. And then you have these little defining words with which you produce something that almost looks like assembler. The only thing in between are these special parameters. Utilizes a special tweak in the 6502 opcode matrix, where there's pretty much one column free that you can use for your own replacement bytes. These are, at the moment of actual instantiating these templates, are then filled with, for example, an absolute address parameter for this sequence, or with a given 0-page pointer, or with a lower and higher byte of an address or something like that. And then the actual code looks, for example, like this. Oops, I can't mark a line here. That you have an immediate load accumulator, which is made up of low-level LDA, LDX, etc., etc. And especially for things like division and multiplication, these code templates, like here at the top, will compile or fill into the binary code a jump subroutine to a runtime module routine. But with this, in this way, I didn't have at that time an assembler or a linker or something available, and I still could get to executable binary code in a relatively straightforward and manageable manner. It's all done almost in a single pass. These code templates, even while the parser is parsing and calling down through code generator to this, I call it virtual assembler, already fills in absolute addresses where they are relevant, for example, for static variables. One trick is that the entire code, binary code for one function, C function, must fit into RAM, so that control structure patches, jump patches forward and backward can be done in this single path. The second pass is then what I call the mini linker, which really just takes the existing runtime module, attaches the generated code, patches, that's the only thing I can't do in the first pass, potentially forward declared functions, patches those jumps into the binary code, and then attaches initialization data for the static variables. Rule is then, if the end product that you compile doesn't have a main function, then the mini linker will write out a new runtime module. So that is kind of the shortcut for the missing library or symbolic linking mechanism. So if you want to build your next programs based on a, let's say, a C64 kernel library, or if you want to build a, which is something that I should do at some point, an actual more or less compatible C standard library, this would be a way to produce this. So the new library would then become the runtime module that you use for the next programs that you write. Yeah, and all that together is 18K of indirect threaded code plus the 14K kernel of FORTH, giving 32K of size of the binary altogether. Further ideas. At the moment, it's running on the C64 and the Commodore 16. I'm in the process of porting it to the Commander X16 new Commodore-inspired 8-bit home computer by the 8-bit guy. Don't know if someone knows the YouTube channel. Porting it to Linux as a host is something that I would like to do, just to make the development easier. Then as a subsequent, I've got pretty decent end-to-end tests already, but unit and component tests would be nice. Definitely get beyond the Koenig and Ritchie calling syntax and enable ANSI style functions. I would like to profile some of this. I'm not quite convinced that the compile has to be as slow as it is. One further idea is maybe at some point to output assembler source. The layered design of the thing is actually made so that that should be reasonably feasible. Maybe even to the point that one could use a symbolic linker. And of course, a C library. That's one of the biggest gaps at the moment, to actually port existing, if small, C programs to one of the target platforms. And I think that's what I have. Thank you very much. Happy to take any questions, of course.
I have a question or a comment. This is really fascinating. You know what would be a great tool if you took this little engine that you created that parses C and outputs a language, you know, compiles it. If you could take your same engine and output FORTH code, that would be a very useful tool.
So basically what you're saying is build a code generator. Yeah, I get what you're saying. Well,
that would be very useful for the FORTH community. We could take C source code that's already written for something and put it through your engine, and then have actual FORTH code. So you've like done half the problem already.
Yeah, targeting FORTH as a virtual machine instead of assembly, like instead of 6502. FORTH becomes the machine code in that case.
Yeah, that's a cool idea.
Yeah, when you look at the recursive descent, oh, my mind escapes me. The recursive
Parser.
parser, yeah, its output is reverse Polish notation code, which then eventually gets translated into assembler, or at that point it can be spit out as forth.
Mhm. Yeah, you probably it could probably be as simple as you would want to build a set of forth words to. So I'm sure there are some operations that the code generator wants to do that your standard forth doesn't immediately provide you. So things like accessing a local variable on a classic C stack or something like that. But yeah, fun idea.
I imagine the challenge would be there's a big gap between outputting some kind of forth code that would work versus forth code that would be sort of readable and understandable, and rather than sort of a low level sort of regurgitation of what the VM was doing.
Very true.
Yeah, that's really good. And so can you run it on a Commodore 64? Is the whole thing actually working? Like you've got 32K of compiler.
Yeah.
And
yeah. This is completely self-hosted.
That's pretty awesome.
Or local. So I actually developed 95% of it on a Commodore 64 with 3 170K disks, 2 for the compiler, 1 for an editor, for a small editor.
Wow.
Lots of 12 screens per page printouts to again and again get an overview. So the current development environment actually is that's actually something I'm to a moderate level proud of. A Vice emulator inside a Make environment, something. Including tests. Run the compiler with C test, producing an output, and then running that output again through the emulator and compare the output of that to the Goldens. So I caught a few nasty division and switch statement bugs with that.
Fantastic. Excellent.
Yeah, then I would say thank you very much.
Yeah, thank you. Okay, yeah, some claps and thanks for that.